Good evening, friends. Hope you're able to hear me. Welcome back to the session, and thanks for your time and joining the session. So I would like to quickly recall what we have discussed so far. So day 1, day 2, day 3, and understand what we'll discuss in day 4, that is today. So first we started understanding what are the applications of ML and AI for trade analytics, how it is going to help. I'm sorry. And then we came back and then understood CRISP MLQ, which is basic methodology, the project management methodology that is followed. And also day 3, with respect to exploratory data analysis, how we explore by doing different calculations. We try to understand the data, and by doing some graphical representation, we do some representing the data with the help of graph, scatter plot, bar graph, histogram, line graph. So there are many graphical representation that is helping us to understand the data. Now today we are going to analyze with some of the machine learning models. Under machine learning, you have two learning models, supervised and unsupervised. So supervised, when you know the output, when the output is known, and unsupervised when the output is unknown. That means simply you will give you the data, and you need to extract and tell me what is that you understood from the data and what is data is telling all about. So that is also a skill of exploring the insights from the data, and later it will be used for predictions and decision making. Under supervised learning, when I say output is already known, the output can be of continuous and discrete. Output can be continuous or discrete. So when I say output is continuous, you'll be calling it as regression model. When it is categorical data or discrete data, then we can make use of classification, because these are all categories, different categories, binary and multiple. So hence, when it is unsupervised, when the data is not known, output is not known, the data can be grouped together, which is having same features or same behavior. So which is group together which is having same behavior. So we call this as a cluster. And then we'll name that cluster which is having having the identical behavior, which is showing some homogeneity, and we'll try to understand what is the identical things. From calculations, we'll try to understand what it is trying to tell. So today quickly we start with unsupervised machine learning model on the trading strategy, because when we analyze the data, we need to predict and we need to take a decision out of it. So before investing in a trade, when you are doing a trade, you are just supposed to compare and calculate how the two companies are, because there will be a number of companies. And when I take top 10 companies or top 5 companies, how the trade is going to happen, how the stocks are shared, and what is the growth, what is the graph. So we need to analyze that particular data. So when I say, when you don't know what is the companies are going to tell, only we know the two companies data. However, we doesn't know what it is going to give you the result. But the data tells us how it has been changed over the period of time. So I can be more specific that unsupervised learning model on time series data. So whenever we involved a time, something like 2010 to 2018 and 2019 to till date 2022. So we are cross verifying with the past history, getting the data, knowing the data, getting the data and knowing it. So this is helpful with the help of unsupervised machine learning model. So what is that unsupervised machine learning model? So we are using k-means algorithm. K-means algorithm. So we'll see k-means clustering algorithm, and then we'll move on to the coding part. So k-means is working on to optimize. So it is an optimization methodology. When I say optimization, it can be having both maximum and minimum. It can be have both maximum and minimum. So minimize within the sum of square, within the cluster variance. So sum of square is nothing but cluster variance. So I'll just tell you what is that. And the steps involved in that particular k-means clustering algorithm is selecting the k data points as k cluster centroids. Let's say example, the data has been divided and it has been given like this. Okay, and the data has been given like this. You assume that I'm going to form from this two clusters, so that this is going to form one cluster and this is going to form another cluster. Let it be two clusters. I can also make it as three clusters, 2, 3, 4, and so on. You can do it whatever you want. But again, the value of k will be decided with the help of elbow curve. This is also a part of it. And you can also give a try by using some of the trial and error method. What is the k value, 2, 3, 4, and so on. So first decide how many clusters you want, and you find the distance between all the data points to all the k centroids. Let's say example, you have these points and you have understood that you need a k clusters or 2, and you will be having 2 centroids. When I say 2 clusters, so this is one center, this is one center for this cluster. So when I say 2 clusters, you will be having 2 centroids. So let us assume that I have taken this as 2 centroids, randomly considering. So randomly considering. Initially, I don't have until and unless I read the data. Hence, what I'll do is I'll mark the centroids initially as somewhere, and you find the distance between all the points towards this centroid, towards this. So whichever it is very nearer, it will join to this group, and whichever it is very nearer, it will join this group. And this forms the clusters. So based on the nearest distance, it is going to assign the value. And you recalculate the centroid by taking average of points which is from a clusters. So you need to keep on updating the cluster because it is going to have a distance. When it is a shortest distance, it will get changed, keep on changing. Let's say example, centroid was here and the points are very closer and it has been formed with the cluster, but it needs to update with the center point. So now the centroid has been updated here from here to here, and it will be updated like this. So this is a centroid. So by taking an average of the points, it will form a centroid and it will get change. So you need to repeat the third and fourth step until you get finished with the values. So until you find all the distances between the points, you need to keep on finding the distance between the centroids and keep on updating the So when you repeat the third and fourth steps until you get, at the end, you will be getting the clusters. So elbow curve is responsible to decide k value. So we can also use a domain knowledge to decide the k value. And between the sum of squares and within the sum of squares, you can also decide. And it is useful for larger data set. When you have more data sets, it will be very useful. And we are not using any dendrograms. So dendrograms comes under hierarchical clustering. Hierarchical clustering. Now we'll go to the hands-on session, but before getting into the practical, I'll just write the flowchart so that you can easily remember. First, you'll start and you'll take the inputs, that is number of clusters. From the inputs you'll decide, and then you calculate the centroid. From the points you'll find the distances, and then you calculate the distance, and you also group the minimum distance, which is having minimum distance, and then you proceed with the third and fourth step. Hence I'm giving here updating with the third and fourth step. So this is how it looks, and the process repeats continuously in the cluster size and cluster assignment with the consistency. So let me take one example so that I can show you how it works exactly. So let me take a whiteboard so that I can explain in this. So let me give you a sample data, sample number, and X and Y. Okay, so I have 1, 2, 3, 4, 5, 6. So I have 185, 72, and 170, 56. Some values 168, 60, and 179, 68, 182, 72, 188, 77. So 1, 2, 3, 4, 5, 6. Okay. So from the given data, I can split this into two clusters. I'll decide and make it as 2. So what is the initial point that you consider? Initial centroid will be considered to be as K1 and K2, that is first values. What is first values? Two values, 185, 72, 170, 56. Randomly also you can choose. And when you calculate the difference between the values, the centroid will be calculated and it will be make a note of it. So how do you calculate? By the help of Euclidean distance, you find the distance form. What is the Euclidean distance? X1 minus y1 whole square plus x2 minus y2, y1 minus y2, x1 minus x2, y1 minus y2 whole square. So this is a Euclidean distance formula we'll calculate. So when you are calculating, So for X and Y, the same distance, it will be 0. And distance between the other two is 21.93. And this is also 21.93. So in this, which is the minimum distance between the first one, and here it is second. So when you have a cluster 1 and cluster 2, so 185, 72, you'll be getting a distance root 0, distance between C1 and C1 itself. Obviously, cluster 1 and cluster 1 itself does not have anything. So from second one, from C2 to C1, the distance is calculated. C2 to C1, the distance is calculated. And when I consider the next, the cluster 1, from C1 to C2, it is calculated. And from cluster 2 itself will be 0. So itself is 0. Now we consider the cluster next position is 168 and 60. So this is the next point. So the distance from cluster 1 and the distance from cluster 2. So it will be 168 minus 180 whole square, 185. This is a 185, 185 plus 60 minus 72 whole square. So you'll be getting 20.80. Okay. So the new point is so the new position is 168, 60. This is a cluster 1 and the cluster 2 is 185, 185, 72. So between these two clusters, I have 20.80 between these two, and next between these two, it will be 4.472. So in both of this, which is the minimum one? It is this. So we'll consider this as cluster 2. So this position, this coordinate, it is nearer to cluster 2. Okay, the centroid is again recalculated and you will be getting the values. Like, how do you calculate the centroid? Again, the cluster K1 and K2 and X comma Y. Earlier, I used to have 180, 72. Now 169, 58. Okay. So for this, you'll be getting 60 plus 58 divided by 2, because I've written cluster 2, so it will be 60, this one, 60 plus 56. I'm so sorry that I have written wrong numbers. See, 185 and 72. So this is fixed. Okay. So I need to update the next. So between these two, I need to get. So 60 plus 56 divided by 2 is 58. So I have updated 58. Now between these two, 170 plus 168 divided by 2. So you'll be getting 169. So I have updated this. So now you got the updated centroid. So this is K1, this is K2. The centroid will keep on updating. Now we have a different formula, different values, K1 and K2. Now we consider the new one. What is the new point? The new point is 179 and 68. This is a new point. So you calculate the distance from C1 and C2. So C1 and C2. So you calculate root of 179 minus, what is a cluster 1? 185. So 185 whole square plus, if it is 185, 72 are there. 72 minus 68 whole square. This is from distance from cluster 1, and distance from cluster 2, you have 179 minus 169. From the previous table, we have 185, 72, 169, 58. So the updated clusters. Don't go with the previous one. 179 minus 169 whole square plus 72 minus 58 whole square. Now you will be getting a value. So for the first one, for the clusters, 7.211, and then here you'll be getting 14.14. So in this again, this is a minimum one. So you'll be considering 179, 68 with the 182. What is 185, 72. So we'll compare that. So 179 plus 185 divided by 2 and 68 plus 72 divided by 2. So we'll be getting this 70, and here you will be getting 182. So now you got updated with the two clusters. What are the two clusters that you got updated? Here I'll update 182 and here it is 70. Now again I need to consider the new one. New one is 182, 72. Now calculate the distance between 182 minus this one, 182 whole square plus 72 minus 70 whole square. You'll be getting 2 square and then 4. 4 is the value. Next, distance between this and this cluster. So 182 minus 169 whole square plus 72 minus 58 whole square, whole root. So you'll be getting 19.10. So which is the one? We got first one. The fourth one. That is a minimum. I'm so sorry. 2. This is 2. So value 2 is lesser than. So then I'll consider the first cluster. So this is a first cluster. I'm taken this is as a second cluster. That means 182, 70 is the first cluster. So I'm getting this portion when I consider distance between this point and the first cluster. So I consider the first one. So now 182 plus 182 divided by 2 and 72 plus 70 divided by 2. So I'll be getting 182 comma. So here you will be getting 72, 142, 71. So it's 182, 71. So the new is 182, 71. So you're updating this every time. 182, 71. Now what is the next point? The next point is one 88 and 77. Now we need to find the distance between this cluster and this point. So root of 188 minus 182 whole square plus 77 minus 71 whole square. You'll be getting the value 8.48. Next, you find the cluster's distance from 188 to 169. 188 minus 169 whole square plus 77 minus 58 whole square. This becomes 26.87. Now you got the first cluster distance is quite interesting and it is very near. So I'll just make sure that 188 plus 182 divided by 2 and you'll be getting the value 185, and 77 plus 71 divided by 2 you'll be getting 74. So this is a new cluster 185 and 77. I'm sorry, that is 74. Okay, so now it is done and you are finished. Now you need to write the final table. So from all the calculations for the given data set, this is the first data set number, and this is X and this is Y. And at the end, I'll be writing assignment, the cluster assignment 1, 2, 3, 4, 5, 6. So I have 185, 170, 168, 179, 182, 188, 72, 56, 60, 68, 72, 77. So when I'm calculating this, I'm very nearer to cluster 1 and this is cluster 2. So initially it will be like this only, cluster 1, cluster 2. Next, this position is very nearer to cluster 2. Now this one and this one. So this is very closer to, again, cluster 1. So now the cluster 2, now cluster 1. This becomes very closer to cluster 1 and this is becomes cluster 2. So you can, when you plot, you'll be getting 2 points here and 4 points here, because all over plus first clusters 4 values, second cluster 2 values. So overall 6 values. So this is how you can do it. So this is one of the method that we follow for k-means clustering, and we have different packages that we'll be using to invoke k-means and then find the values. So we'll see that hands-on and try to understand. So stock market clustering, in this work, we'll be using Pandas data reader to read from the internet source. So we are using Yahoo Finance, so which is going to give the data of different companies in that particular. You can see that Y Finance. So just show you Yahoo Finance stock market live. You can see that S&P, Dow, Nasdaq, Russell, crude oil, gold. So these are the stock market details and their prices changing, open, close. Okay, so this is I thought of showing it Nifty. I'm not getting it. Okay, so this is a page where we'll be using. Okay, so for that you can use data reader from the web, that is web scraping. So pandas underscore data reader needs to be installed, and you need to install plotly. Okay, and we'll be using matplotlib.pyplot date time because it is a time series, and numpy. So companies are like Amazon, Apple, Walgreens, Boeing, Lockheed, McDonald's, Intel, IBM, Texas, MasterCard, Microsoft, American Express. So like this, we have various companies stock details, and we'll consider the data source from Yahoo. And we are considering the data from 2015 to 2020, from April 25th to April 25th. So we'll be storing that in a values like data source, start date and end date. And we'll be using Google Colab for the same. And we have df.it. The first 5 rows will be listed here with all the companies and their volume. Okay, so we'll find whether this particular data frame contains any null values or not, and if that is the case, then you list here with the values, and better that it does not contain any null values. And this is one of the part of exploratory data analysis where you check for the feature engineering, where you check for the data null value or not. And then we'll move with the opening and closing price of the particular day. So when you have a positive moment, then it says that you can go long on stock and or buying the stock. And when it is negative moment, you can just give the saying that you just go for the selling. So from the graph, so open and close, open will be on that particular day start, what it will be open, and the close will be on that particular day at the end of the day, what is the close. So it is going to calculate and give you the value open and close, and these are some of the values of that particular companies. High, that is a column, the company name, the change, and the high, how it has been calculated with the data. So we'll consider two companies, Amazon and Apple. You can also do it with the other companies as you wish, and we'll plot the graph by 20 by 10, considering the opening price and Amazon plotting. The font size is 15, and this is a details of Apple company. So you can just see the plotting. So you can just plot this using with the help of plot. So I'm just hoping that I'm concentrating on Apple, I'm given, and whatever the value it is, open. So company name Amazon with the value open and close. The first 30 days are plotted against date, and the next it is with respect to open and close. So location upper left, frame on with false, frame alpha with 1, and probability with size, properties of size is 22. So you can just change it and then try. So the date will be with the x-axis and the y-axis, the movement. So you can see that movement has been plotted on the y-axis and the date is given on the x-axis. So the company name Amazon, this is Amazon, and here probably, so it is taking different, and here it is taking volume. There it has been taken a movement. So here it is taking volume, data, date and volume. So this is for Amazon and this is for Apple. So now we need to normalize the given data, and when it is normalizing, we are finding the values with the minimum value, maximum value, and the mean value. So after normalizer used, it need to fit transfer movements which you get from the data, and your maximum number, minimum number, and mean value. And after doing all these, we just need to go and calculate which is better with the help of k-means. How many clusters can be formed, which group it belongs to. So for that, we have a pipeline and make it following in a particular clusters, the normalizers and k-means. When it comes to cluster, k-means need to be imported, and you need to create a k-means cluster model. So you can just give n underscore cluster as 5, 6, 7, 8, 9, 10, anything. And maximum iteration is 1000. So we'll make a pipeline chaining normalizer and k-means. So pipeline make underscore pipeline, the normalizer k-means, and pipeline dot fit predictions pipeline dot predict of moments, that is going to predict with the daily stock moments and then predict the values. So when after prediction, when you list that, you'll be getting 2241 81 9272 and so on values. So later you'll shortlist the labels with the companies, list of companies, and then you sort the values by labels. So here you can see the labels are 0, 1, 2, and 3 and 4. These are the groups that has been formed here. So with the help of k-means, this is a package that is going to perform. 1000 times it is going to perform, 10 groups it is going to form. 0, 1, 2, 3, 4, because the data is huge, right? So you need more clusters. So it is formed. So at the end, I can show you that this is a clusters. Cluster 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 clusters, 10 centroids, and you can plot the graph. So this is all about with respect to k-means clustering. And here you can also give a try for principal component analysis, where you'll be having more features and it will be reduced. So for principal component analysis, we have a package decomposition, PCA, reduce data with PCA n underscore components, with transfer and H value, plot the decision boundary and obtain the labels for each point, and you train the model and you get it for k-means cluster. So this is a simple one where this can be made a group of companies which is having the same stock price, and also you can analyze and predict and make an investment when you have a option with the two clusters. So hope you are able to follow me. If you have any doubts, you can just ask me. Okay, friends, we'll stop here. If you don't have any discussion, we'll stop here and we'll meet tomorrow with the next method.